The next talk is The Critical Making Movement by Regina M. Schipus and Saad Shinoy. And please give them a great round of applause and welcome to the stage.
You'll do wonderful.
Thank you very much. Hi, everyone. My name is Regina, and that one over there is Saad. Ricardo unfortunately couldn't come today, so if you wanted to see him exclusively, then you are now free to go and get a mate for yourself. That means, though, that we are going to have a bit more time for questions, so if you already want to start thinking about what you want to ask us, we would be delighted to have an open round with you. My name is Regina Schipus, and I'm doing my PhD dissertation, writing it about the social innovation in critical technical practice at the Technical University in Berlin. In this session today, we would like to give you an overview of what critical making is, or what it actually could be. It is a relatively recent notion, so there is still a lot of space for different versions of this idea. We will also present to you how around the world academics, artists, citizens, and grassroots communities are engaging in this activity. The point of such practices in academia is to teach critical thinking about socio-technical relations. In art, it is to get wider audiences to think about our relationships with technology. And in grassroots movements, people focus on how to help people understand that it can also be used for social change and to improve the lives of their communities. DIY and making is a fantastic way to allow people to better understand this inaccessible black box that we today see technology as. And so it can help create a better connection between society and technology. But it is actually a relatively recent notion to use critical thinking in the DIY culture to, as Garnet Hertz puts it, look beyond the idealized picture of the maker and to reintroduce a sense of criticality back into post-2010 maker culture to unsanitize, unsmooth, and repoliticize it. Firstly, let's talk about making in general. If you define making and maker spaces as community spaces or third places where people can make things, these have actually existed for a very long time. The American Libraries magazine starts the timeline of the history of making with 1873 in New York, with the Gowanda Ladies National Social Society, which was formed to kilt, knit, sew, socialize, and talk about books. Now that was almost 150 years ago, and today we're talking about this phenomenon called the maker movement. So how did that actually begin? There are two main events that I would like to point out, and I know that a lot of you have already heard about these. One was the Makerspace, which has its roots in MIT's Center for Bits and Atoms, and the course How to Make Almost Anything. The other one is the Make magazine, which really kickstarted the rapid growth of the movement in 2005, together with its maker fairs. So maker, hacker, innovation spaces, whatever you want to call them, are actually a rapidly growing phenomenon, and really rapidly. Between 2006 and 2016, only in 10 years, the number of such spaces worldwide has multiplied by 14. There are many of these spaces that rely on their members and want to create communities for them. And they want to use these communities to create artifacts that improve the lives of people in these communities. Makerspaces, though, don't necessarily self-identify as spaces of social innovation, but a lot of them still have effects on societal issues because they engage in a number of different areas. For example, educating people. They make knowledge about technology available for everyone through local events and workshops and even online materials. This picture, I mean, not in this picture, is me at the age of 33 last summer trying to figure out how a radio actually works. They also strengthen democracy. They offer third places for communities, and they support civic engagement. They do this through notions of activism and critical thinking, and thus they unlock grassroots capabilities, like these 4 people here, soldering or not, in Singapore. They also create and support new models of production through access to personalized manufacturing and rapid prototyping. They also engage in the commons and create open source solutions. They produce open source software, hardware, or use peer production and make blueprints available online. This example from open source ecology is on the Global Village construction set that makes tools for building and sustaining a whole civilization. This is available for free online. One of the examples is, for example, how to build a machine that you can use to press bricks. The members of makerspaces also create innovative artifacts. By using critical thinking and different design methods, they support the creation of socially relevant works. This is an example from Carables called Made for My Wheelchair, which is a very interesting thing because there hasn't been a lot of innovation going on for users of wheelchair for a very long time. And so these people, by collaborating with the users themselves, added appropriate technologies like lights or this trolley that you can see in the picture, and so improved the lives of wheelchair users. By focusing on awareness raising, for example, on sustainability, in terms of hosting repair cafes or operating by default as eco-fab labs, or simply allowing local manufacturing instead of long delivery routes, they actually, some of them, add to sustainability. So more and more people are starting to see making as a tool for empowerment and change, and it is really such a great tool that has the option to democratize technology. However, these solutions that they come up with are often neither sustainable, nor long-lasting, or impactful. Let's explore some of the reasons why. There is obviously a lot of hype around making. Chris Anderson even called it the new industrial revolution. Whether that is true or not is debatable. It is very nice that more and more citizens feel engaged, that, for example, Obama endorsed making by hosting a maker fair at the White House. This shows that it really has become a mainstream activity. However, for example, when MakerBot became closed source, or the maker culture started being co-opted by the military, by DARPA, a lot of people have become disillusioned. Unfortunately, what we see more often than not is especially a DIY-type consumerism. This is an idealized new world of empowered consumers who are led to believe that they can take things into their own hands, but they do not engage in critically thinking about the effects of their hobbies. Like, is it, for example, really the best way to use 3D printing technology to print hundreds of plastic Yoda figures? A lot of this criticism can be seen on Garnet Hertz's hilarious version of a fictional Made magazine with the subtitle Technology on Affluent Leisure Time, such as Open Source Secret Revealed, everybody just buys the kit, or how to use the MakerBot to make a 3-cent piece of plastic. As Hertz defines it, this version of maker culture is makers equal hackers minus the controversy. This picture painted of the maker movement definitely lacks hacker visions, as we know them. It is very difficult to find the countercultural aspects in maker culture today. This mainstreamness has also brought with itself a Silicon Valley ethos. Make magazine is indeed a fantastic publication, but it only focuses on a particular, apolitical, market-driven segment of DIY. Through predefined activities and kits, there is very little space for creativity, speculative processes, or reflection. We should also not forget that wherever the funding is coming from for makerspaces, this will have an effect on the practices, and so a lot of makerspaces will be forced to go into directions that their members might not agree with. What people start to see is that an alternative is needed to the Silicon Valley type of ways in which we innovate socio-technical systems. Makers often use standard engineering practices, and this is why they're actually limited in their societal impact. If we want to innovate for society, it is required for us to rethink how we innovate. We have to maybe start from a different position, because reproducing industry practices has clearly been insufficient. Critical making as a term was initially developed about 10 years ago by Matt Ratto. He was inspired by Egri's paper on critical technical practice, lessons learned trying to reform artificial intelligence from 1997. Ratto originally wanted to develop innovative scholarly practice. As he put it, critical making is an illusion of two typically disconnected modes of engagement in the world: critical thinking, which is often considered as abstract, explicit, linguistically based, internal, and cognitively individualistic, and making, which is typically understood as material, tacit, embodied, external, and community-oriented. So the roots of critical making are in critical technical practice, but also in critical design and critical engineering. Even though today critical making seems to be an umbrella term for a mix of such activities, all three are also still alive and well and thriving in their own areas. As I mentioned before, Egri wrote about critical technical practice in 1997. This was a critical theory-based approach towards technological design. He aimed to increase awareness and critical reflection on the hidden assumptions, ideologies, and values underlying technology design. Critical design has also been around since the mid-90s. As Dunn and Raby's book called Speculative Everything writes, critical design uses speculative design proposals to challenge narrow assumptions, preconceptions, and givens about the role products play in everyday life. What you can see here is their work called Designs for an Overpopulated Planet, Foragers, and it's dealing with the question of the world running out of food due to overpopulation by about 2050. If governments and industry are incapable of dealing with the situation, which is the case in the speculative vision, can a group of people take their own fate into their own hands and start using their knowledge to build DIY devices, to put simply, suck nutrients out of nature? So Foragers is about the contrast between bottom-up and top-down responses to a massive problem, but also the role played by technical and scientific knowledge from the grassroots. This is all speculative, so later on, DeSalvo raised the question during his Growbot project, what should actually come after these imaginations of possible futures? In critical engineering, we see two directions. One is the pedagogical way, incorporating critical thinking into engineering studies and the teaching process, and asking questions about the engineering itself, like the production of technology and our relationship to it. Who does engineering and for whom? Who benefits and who loses from engineering? What you're seeing here is the Critical Engineering Manifesto by the Critical Engineering Working Group. Some of the most important points that they raise in this manifesto are raising awareness about techno-political literacy, deconstructing and inciting suspicion of too rich user experiences, how each work of engineering engineers its own user, proportional to the user's dependency on it, or what the critical engineer notes, or that the critical engineer notes that written code regulates behavior between people and the machines that they interact with. By understanding this, the critical engineer seeks to reconstruct user constraints and social action through means of digital excavation. This leads us to one of my favorite examples of critical engineering, which is Julian Oliver's Harvest. This is a work of critical engineering and computational climate art. It uses wind energy to mine cryptocurrency, the earnings of which are then used as a source for funding climate change research. What do we see in teaching? Teaching critical technical practices in critical making can mainly be currently found in the United States at Berkeley, Stanford, and NYU, and Canada at the University of Toronto and Emily Carr. Most focus on helping students with theory and methods to think more critically, creatively, or even radically, and to think critically, creatively, or radically about possible future human-technology relationships and explore the social issues that are inherent in technical systems. Interestingly, I actually also found some examples of critical engineering practice in post-Soviet countries like Kazakhstan, where critical thinking already seems to be cultivated by the Ministry of Education. Maybe something we can learn from. There is also more and more going on in research. There is a Dutch critical making consortium, a 4-year project titled Bridging Art, Design and Technology Through Critical Making, in which they are trying to figure out how 21st century creative practices like art, design, and making can overcome the industry logic of techno-optimistic makeability and aestheticized products of the creative industry. Another direction is taken by a research group at the Weizenbaum Institute in Berlin, in which they focus on the production opportunities of maker culture, for example, through DIY development. They research makerspaces and open labs with a societal impact, not only in industrialized nations, like the USA or South Korea, but also in emerging economies in Brazil and China, as well as developing countries. The other direction we see today in critical making is looking at the wider world. Questions, for example, how access to technologies can create active citizenship, or looking at art and design and how it is used in activism, or even grassroots and criticism-driven practices. This might be familiar to some of you. It's right outside our door here. As Ratto and Bowler put it in their book DIY Citizenship, DIY citizens understand their work to be socially interventionist and ask themselves, how do we engage with society politically through technology? Individuals and groups who are self-organizing, enabled by social media networks to scale up and cross the borders of the state. DIY citizenship has become a prominent political theme in the face of rising disillusionment with politicians to act effectively on behalf of citizens. One example in the book is also the craft communities of knitters who form and express citizenship identities, which might, if you think about it, be dismissed as just groups of hobbyists. But actually their online networks provide opportunities for new forms of connective engagement to emerge and counter the pessimistic trope of civic decline and apathy. This example from Golan Levin from the Carnegie Mellon University is called Free Universal Construction Kit. He made it for his son to be able to put together different toys and assemble something new, create a bridge between closed systems. As he puts it, the kit is a matrix of 76 adapter bricks that enable complete interoperability between children's construction toys by allowing each piece to mate with each other. The kit encourages totally new forms of intercourse between otherwise closed systems, enabling radically hybrid constructivist play and the conception of before impossible designs. It is a grassroots interoperability remedy that implements proprietary protocols in order to provide public service unmet or possibly even unmeetable by corporate interests. He calls this a reverse engineering as a civic activity where objects prompt critical reflection. He actually compares it to the VLC media player and its ability to play different formats across different platforms. It was Garnet Hertz's objective to expand the term critical making as an appeal to hands-on makers in makerspaces to be more critically engaged with technology. He has been actually collecting a lot of really good projects from around the world in the following two booklets. The first one, Critical Making, which consists of 10 pocket-sized booklets, and the creation of this was a critical making project in itself. Originally, one PDF per day was released through the Twitter account at Critical PDFs. The topics of these zines were, for example, manifestos, terms, projects, and conversations, and it also included some of the interviews that he's been conducting, for example, with Phoebe Sengers, who develops a new kinds of interactive technology that respond to and encourage critical reflection on the place of technology in culture. Or with Natalie Jeremijenko, who blends art, engineering, and environmentalism to create real-life experiments that enable social change. Followed up by Disobedient Electronics Protest. This is a zine showing projects with the aim to point out other different foods for thought. All of it, of course, available online. So last August, at the Weise 7 studio in Berlin, including me, a number of people spent 3 hot days while it was raging heat wave outside, 35 degrees, with Brett Barloch building the Wilderness wireless device. This is a device that is a solar-powered, plain, simple, little Wi-Fi access point and web server. It has been inspired by the free radio movements, and these 3 days actually gave us a lot of opportunities to discuss and share thought about socio-technical questions, questions of power and creativity and sustainability. Also, who owns radio frequencies and who has the rights to use them? Of course, we also had to talk and think about where the parts that we built together were coming from and how the metals for these parts were sourced. If all goes well, my critical access point is online now, and I would actually like to ask you to take out your phones and look for this in your list of available Wi-Fi networks. People in the front rows might actually have a better chance at getting at it. But what I'm trying to show with this is that this is a simple device that you can use to tell people about issues that are important to you that they might otherwise not actually hear about. Is it working? All right. I highly encourage you to look for the hashtag on Twitter. So now I would like to zoom in to critical making that is done by grassroots, because these following examples that are going to be presented by Saad are actually going to be coming from that sphere. What you need to know from an academic point of view, the trouble with these is that they are difficult to research because, of course, most such activities are decentralized. There is not just one keyword that you can look for, and this is what makes them so difficult to locate. The taxonomy is simply not there yet. Once institutionalized, they are also influenced by where the money comes from, and often the political activist roles they play diminish. Societal impact is in fact high in those grassroots spaces and movements that use critical making. They not only use this to raise awareness and hopefully change the status quo, but also to have the capacity to minimize negative effects on society and the environment that technology might have. It is the ingenuity of human creativity to hack for society, what Saad is going to tell you now about in the following case study. And I thank you very much for your attention.
Well done. So my name is Saad, and I am very much an example of all of the things that Regina's criticism is directed at. I am a technologist. I'm the stereotypical IT guy from India. I live and work in Singapore, but I'm also a maker. My day job keeps me going, and I work in digital publishing, but we like to work with non-profit organizations. And that kind of is my approach to what technology is and should be. It should be used for good. The area that excites me the most is the overlap between the physical and the digital. And this is an area that lots of people are exploring, but in particular, the Internet of Things. And I know from talking to people here that there are many in the room who are excited much in the same way as I am. But what this is about making things and looking at technology in a more hands-on, accessible kind of way, where you could imagine putting together a digital recipe, much the same way as you would put ingredients into making something delicious and edible, not unlike a Raspberry Pi. So I like to play with things. I like to play with tangible, physical things, even though my day job is all about technology, building for the web, ebooks, that sort of thing. But the tactile tangibility of technology is now something that is a lot more real for us. I am a maker, like I said, and this is probably something that people are familiar with. Technology does go bad. It goes wrong sometimes. And that's kind of the fun part of it, when things are unexpected. When things happen that are unexpected, something new comes out of it. And I am also a big, huge fan of 3D printed rubbish, but it doesn't always have to be rubbish. I'm a Star Wars fan, but I haven't to date printed a Yoda head, which I think is something I'm proud of now, having heard what Regina had to share just now. But I do like maker fairs and fairs that bring people together using these sort of tangible aspects. And you get to meet people, and this is kind of what Congress has been for me, where you have this interdisciplinary kind of thing happen. I mean, yes, the maker fairs attract a lot of criticism for being incredibly commercialized, and this is justified. But you also have spaces where this kind of thing is possible, where you can get people that you are familiar with, makers, to pose for an Instagram photo where you're pointing at things and pretending to look very interested at something that's 3D printed. But I make things. I'm a crackpot, as the original word describes. A crackpot is an inventor, and I invent things. This is a true product of my geek background. As a lot of programmers know, a programmer is someone that converts caffeine into code, a lot of the times, not all the times. So the caffeine thing made me make a caffeinator, which is a coffee machine made out of clothes hangers. And of course, there are strange things. This is a jellyfish. It's actually a shy jellyfish made out of an umbrella. As somebody approaches it, it shies away. And it's also connected to the internet, as everything should be. I'm unfortunately also guilty of contributing to the world of selfies, which is a world that we very much live in, with this tangible thing, which is a selfie booth. You go into it, and it is triggered by a button. You sit down on this button, and it takes a picture using what is known as, what has come to be known as the world's lowest energy consumption, purpose-built, highest resolution selfie display, also known as a mirror. It then uploads said selfie to its own Instagram account. And that's kind of what you look like when you're in there. It's a bit ridiculous. And it's open. It's open in a familiar kind of context, which you probably have seen this in catalogs, and you can get most of these pieces that are mass-produced. So what I really like about this is that by just adding a little bit of digitalness to something that is ridiculously mass-produced, you're able to create something completely new and interesting and fun out of it. It also allows me to do is to work with other people. The interactivity that takes place around the artifact, the object, the technology, is what makes it fun and interesting and engaging to me. I mean, what I like to see is how kids and other people who are clearly inspired by selfies, the way they interact with these objects is not how they would normally approach a Raspberry Pi. They use the thing and then they ask the question is, how does it work? This is another example of a dinosaur which was designed specifically to introduce, as an educational thing, to introduce children or young people to cloud services. So there is a paper-folded origami dinosaur, which is a T-Rex, that is connected to the internet using very simple connections. And so it's an IoT Rex, which you can trigger from your phone. And sometimes it works. Last but not least, there is the cloud, which is an example of something intangible made tangible. When we think about the cloud, we think about many different things. Especially in this context, it's digital in nature. There's layers of abstraction. I tried to make this manifest in a physical form, where it's a lamp that is connected to the cloud. And it is here at Congress. If you use the hashtag, if you tweet with the hashtag 35C3, it goes all sparkly. And if you use the hashtag Labmobile, it turns rainbow. And some of you probably have noticed the Labmobile parked right outside the Borg. It's just behind the Kiosk West stage. So I encourage you later on to take a look. This very happily links me back to why I'm here. And what I would like to share with you is a story about a button. But I'm part of a group of innovators. The Global Innovation Gathering is of which the Labmobile is actually part of. This is the family, and I absolutely love everybody in it because the minds and the frequencies that we think in are along the same ways. It's all about innovation and sharing. So, in summary, this is what I'm about. I love the idea that hackerspaces and makerspaces can overlap. And there is this delicious layer that forms when these things overlap. And of course, I need a day job to sort of make this sustainable. And these things kind of wobble around a little bit, so these Venn diagrams are not static. But the thing I wanted to talk to you about is a story about a button. There is a small group of people, and when I say small, it's 2 employees, in Singapore, which is a non-profit organization called Engineering Good. And they take after the Engineers Without Borders. But they're based in Singapore and is composed of engineers from all backgrounds, not just software, who do various kinds of infrastructure projects. But also in Singapore, they focus on this overlap, which is about the use of appropriate technology and customization for working with persons with disabilities. And that is the story about the button that I like to share. The good people at Engineering Good have several projects, both local and international. But the key focus here is a story about assistive technology for PWDs, which is persons with disabilities. And the workshop that I got terribly interested with is the Hack a Toy workshop. And Makey Makey is kind of what drew me to this because it's one of those techie things that's made into the tangible space. The problem that was defined was that assistive technology is expensive. This is a snapshot from a website, and you'll notice the prices are ridiculous. I mean, if we look at the big red button on the bottom right corner, it says $65 US. And that's a button. There's nothing complicated about it. It doesn't make breakfast. It just is a button. when you press it, it either turns something on or turns something off. That's what it's designed to do. So the people who use these buttons and assistive devices are the caregivers. This is an example of the community of people that Engineering Good works with, and they are usually in community centers or social enterprises where children and persons with disabilities come and spend the day and are taken care of by these people. So these are individuals. So this, what Engineering Good does is to train the trainers. And they defined a situation where the children needed to play with things. And we are incredibly privileged. We have fine motor control. And I don't mean, the ability to drive cars. I mean the ability to use our fingers, the digital dexterity, pun intended. But with persons with disabilities, they have no fine motor control. They have gross motor control. That's why you need a big fat button. You can use your entire hand. And these things tend to be very practical, like opening a door, or turning on a light, or turning off a light, or turning on the air conditioning, because Singapore is very hot. But there's nothing playful about it. So what the Engineering Good team did was to find a way to merge the two by taking apart a little toy and plugging in one of these big red buttons to make it fun and interesting. The same button that you would use to open and close a door, you can now use to sort of activate a toy. And these toys are cheap and cheerful. They're very easy to buy in large quantities and then modify. So you don't have to make something from scratch. The other problem was that the cost of this button is still incredibly high. And for people who are taking care of persons with disabilities, the cost is a limiting factor. And so the engineering team did design thinking approach and got all the minds together. And again, I just want to point out that we're all volunteers, right? They all have day jobs. They all come from like corporate companies where the stationery is expensive. But they noticed that all of these buttons have a fairly standardized connector. And you're probably all familiar with this. This is a sort of headphone jack, but it looks slightly different because it's mono rather than stereo, because it's just got two bands. One band and two metal parts. And each button is connected with one of these things. So you can interconnect different buttons to a toy. Also, we realized one of these works exactly like a button. I mean, it's a tap light or a touch light, they're known as, and these are mass-produced to ridiculousness. So they're incredibly affordable, and they're everywhere. So what we did was we took it apart and found a way to connect that touch light to the system that is used for assistive devices, using that common connector. And so the ability to sort of look into things and take things apart and then rethink it without having to 3D print or reinvent or do something that has been manufactured. We just take something that's already been ubiquitous and manufactured and modify it, which is a lot easier. And this is effectively the solution. So what you have on top is a little piece of copper, which goes into the toy and it acts as an interrupter. It basically blocks the connection for the battery to make the toy work. And on the bottom, you have the other half, which is a light that's been turned into a button, and you have the connectors, so you can interchange them. And so what you have is something that is cheap, cheerful, very easy to hack, manufacture, to modify, and also to teach. So this is what we do with Engineering Good. We teach the caregivers how to modify these lamps. And it's fun. You can do, because you're playing with not only the idea of rethinking something, but also with the thing that you've made. It's a toy that you can then trigger and turn on and off. And this is the moment that sort of makes everything worthwhile. Everybody's trying to get just this to happen. So you have this little tactile thing, you touch the two contacts together, and it activates the toy. You're not limited to just buttons. You can use something like a clothes peg. This is used to hang clothes outside to dry, and that you can put a switch inside. So there are various kinds of switches. These are the 4 that we've come up with. You have a little doorbell there, which is again very commonly used in Singapore. Clothes peg, little alligator clips, and a touch lamp. Again, same basic idea, the common connectors in between. So they're interchangeable, and depending upon the tactile abilities, you can make these. But the idea behind that is you accidentally learn how to work with these tools. And when you are a caregiver and you're doing physiotherapy and things like that, you don't usually have the time to go and attend a skills training course where you learn how to solder for the first time. But when you put it into context, and we're talking about modifying things or hacking things, it becomes interesting, and you sort of accidentally learn how to work with these tools. And it's fun, which is the cool part. Because you've got these little toys that are mass-produced, and they're just, when you turn them on, they're just always on. But the minute you add a little button to it, they become interactive. And suddenly you have this sense of control, which somebody with disabilities is having trouble coping with. It's incredibly rewarding. The feedback mechanism is brilliant. Just the fact that you're able to control something for fun. So this is us. This is a group of, this is what we typically look like, and all the toys that we've built. They are constantly looking for help and support, and I think the potential in this room is phenomenal in just the brain capacity, but also in the capabilities of what we're able to do. So Engineering Good is a non-profit organization. It employs 2 people. It's based in Singapore. It's a registered charity, and they're always open for donations. So if you're interested, do contact us at any of these addresses. And that's all I have for now. Thank you. Questions?
Thank you so much. So now we have time for some questions from the audience. Please queue up by the microphones. Don't be shy. Great. Microphone number 1, please.
Hi, I like the presentation very much, and I have a question for the audience actually. Who would really consider working in Asia in one capacity or another? Please show hands. Okay, anybody interested in China can find me later. Thank you.
Thank you for that.
Okay, but actually I was wondering, I think it's really great, empowering people, especially with disabilities, considering how hard that can probably be. So you've been working with this now, so what was your biggest surprise through this project? I guess that you must have stumbled upon something that kind of made you think, oh, wait, I didn't consider it like that.
That's an excellent question. The thing that led me to this was a volunteer job. It was a way to get away from the mind-numbing, mundane, day-to-day job of working in technology, but also trying to, be amongst other engineers that were not maybe software engineers. So it was accidental that I stumbled upon this idea of hacking the toys, and then I found myself drawing parallels between the hacking physically versus the hacking that we do with technology. The code lends itself a lot, much easier to being modified and changed. So you get somebody else's code for free and then modify the hell out of it and then try and make money from it. That's roughly what it says on the tin. But when you do that with something that's tangible and physical, it becomes #IRL. It's immediate. And that is intensely rewarding. I wasn't expecting it to be rewarding. So just this act of doing what I do in the digital space, doing it in the physical space, was very cool.
So maybe just essentially, how little it actually required to do this much of a empowerment of this group. Yeah. Nice, great. I think we also have a question from microphone number 1.
Mm-hmm. So thank you for the talk, and I have a question for both of you. Because Saad, you said that you're working with ebooks, with books, and I also have a question towards the critical making. So how can we actually teach other people the narrative of critical making, especially to the kids? Because I find that a lot of what is being promoted towards the kids, a lot about books, about making, they are about this really just playing with technology without criticizing it, without thinking how it is designed, without thinking about the disabled people and how they are excluded out of it. How can we tell stories? How can we teach young people to think about technology as something they can modify and they can take a part of in designing?
I have some ideas. Should I repeat the question, or is it?
No.
Yeah, okay, perfect. Right, so that's exactly the thing. We're so much at the beginning of this whole, critical making thing that I think people who are engaging with it are the people who are already in technology and are like trying to make a difference there, or in engineering studies, or in some maker spaces at big, rich universities. And so I really like your question about how can we essentially start earlier with that. And maybe what we need is, a critical making playbook for children. It's definitely going to have to be something, so to say, interventionist. So classes, even why not at maker spaces? They already do so many classes for children. Why not bring in some of the critical thinking tools into this? The problem is, of course, that a lot of maker spaces also don't engage in this generally. So, focusing on children's education would be even a further step than that. I think that, us here as parents have a perfect opportunity to start doing this at home, even if it just starts with minor critical questions about how we use technology. Why do I not know what is in my phone? Why can I not take it apart? Why don't I know where the parts of it are coming from? How does it influence me? Why, I'm teaching at the Technical University in Berlin. The question of how do we get the children to get off of their phones it keeps on coming up. So there are a lot of questions. Some people who start thinking about this, and I think that there are good opportunities, but people have to start doing it. Oh.
I agree. I mean, I think that to address the question, yes, there's definitely a need for more of these stories to be out there. And the examples that we shared are some of them. It's a snapshot of them. And people relate to things that they find relatable. So these stories need to come out. And it's a challenge that even in Southeast Asia, we are trying to deal with, where there is no good content that represents the Southeast Asian mindset, especially for children. And so when it comes to persons with disabilities, there are very few stories that are well told. And so there is a need for this. And there's a constant search that we are on the lookout for good content. And what we find with children, though, is a very interesting sort of retro thing going on. I mean, yes, technology, digital natives, yes, and parenting is often whittled down to just give them a screen and that'll keep them quiet for a while. But the content on that screen needs to be part of your parenting. You have to choose what your children are exposed to, not just the fact that they're looking at a screen. But what we're looking into now is very interesting and exciting, which is the comic book format. And that seems to be working really well, not just in the digital space, but also in print. So children would like to have printed out comic strips in sort of Instagramized format, if you like. It's a bit weird retro thing going on, but that seems to be interesting. That's what we're looking into now.
Great, thank you. And microphone number 3, please.
Thank you. I think my question is kind of similar. I always wonder, do we see the real problems? Because I think this all is focused onto some very limited group of technically interested people. And I constantly see myself not really understanding the problems or perceived problems. of the common working man and woman. So my question is, how can we get out of a very educated bubble and really create things that are important to many people?
That is such an interesting question too. I spent half of my Christmas debating the exact same thing with my family at home. And I mean, I don't know. Because we live in our own bubble, as you said, and that is such a different bubble. And that's actually where a lot of the changes that we are creating kind of, trickle down to and affects the lives of those people. So how can we actually engage on eye level with those who are influenced by the technologies that we are creating? I don't know. Do you?
I don't have a direct answer to that, but I can share what works for me, which is that I found that stepping out of my comfort zone really had unexpected benefits, as in like the question you asked earlier, what was unexpected about this, which was that, just the participatory design approach, I think we're onto a good idea here. The idea of having design be participatory, instead of this whole trickle-down, top-down, waterfall model, all of that rubbish. If it is participatory by design, I think, that's a step in the right direction. And all it requires from my part was to recognize that I'm in a bubble and then try and do something about it. I think that's a good place to start.
Thank you. Microphone number 2, please.
Thank you very much. That was such a good talk. And my question goes into a similar direction, probably more tailored to people here at Congress. Would you have suggestions for, like, if I'm a German hacker maker that wants to get more engaged in critical making because it's personally rewarding and socially important, where do I go except for talking to you guys?
Yeah, you're a German hacker. I mean, I ended up going to the summer intensives at the Weise 7 studio in Berlin. I am afraid that there's very little of this going on still in Germany, and that's actually one of my research questions too. I would like to write a case study about critical making in Germany. I find it extremely hard, and so I wonder if there is a level or lack of democracy, for example, that's needed for critical making to happen, where people actually have to take things into their own hands and drive innovation forward for themselves from a grassroots perspective. So at the Weise 7 studio, it is about critical engineering. It is still very close to critical making. And that's definitely a good starting point. Yeah.
Just to add to that, I mean, with Singapore, because the question's about Germany. With Singapore, there are a few options. It's not just here that there are lack of options where you can explore this sort of thing, because it still needs more attention. But there's a nice overlap between art and science, and it seems to me that artists seem to be the ones asking these kinds of questions. So I guess my response would be to engage with artists. But I've just realized events like this are plural, they are inclusive, they are participatory by nature. I mean, it is incredible what I've experienced in the last couple of days, how this Congress has come together. And you just have to look at angels. Be an angel, I think, would be the perfect thing, because then you're volunteering, you're stepping out of your comfort zone, and you are exposing yourself to ideas that would otherwise you would not expect. You don't know what to expect as an angel, so you don't know what you're going to find yourself in, and it's a problem-solving challenge. And I think I think that's a good way to start.
It is a good way to start. Also, maybe when it's not Congress. Hackerspaces are supposed to be politically more engaged than plain makerspaces, and so maybe there. I had a really good discussion with a hackerspace recently, and they said, well, hey, if you want to come here and do this yourself, then that's fine with us. We don't really know what you're talking about, what you want from us, but you can do it. So maybe I will, and then I will invite you.
Nice. Thank you. Microphone number 2.
I really liked the tension between the first and the second presentation. You have to be careful of it, and then you still have to do stuff. So I definitely get it. But I'm worried about the space that's left for failure and trying stuff that might make no sense. Well, my question is, how can you be critical about critical making, and what are the scientific publications on it where I can see the size effect and the validation of those practices?
Right. So critical making. Yes. I think failure. The nice thing about generally about critical technical practice is that it does not necessarily push for a successful artifact. It's not about creating something brand new that then millions of people are going to buy. A lot of this is just non-market type of exploration of technologies. You're free to play, you're free to fail and create, even monsters if that's what you want to create. So I think that's definitely, I think also often inherently in making generally, failing and making weird things is allowed. What was the second part of the question? I couldn't.
To have just scientific publication to see what are the impact on the guidelines that it's actually
Right. I mean, scientifically seen, yeah. This is why I like to research grassroots groups, because they make up their own rules. And I think that that's just a fantastic approach to how we actually want to run our own world.
Thank you. Microphone number 1, please.
just one.
Please move closer to the microphone.
Yeah, I buy everything except this trickle-down approach. So this is from the opposite of grassroots. So you don't have an academic idea and then it trickles down to the rest of people. If you are in Berlin, there are examples like openwheelmap.org from the Sozialhelden project. So they are handicapped people building their own application and looking for funding, and they are quite successful. So it's possible. You need people who are really involved, and this inclusive approach is working, but additional funding is another problem. You need funding for this. There are established models to get funding.
Yeah, thank you very much. I think Sozialhelden is just a fantastic group of people. And yes, you need funding, and maybe that's something that we should kind of try to reinvent for the whole world, that people who are doing good for other people don't have to look for, don't have to struggle to look for funding and be able to pay their own bills on a daily basis. So, yeah.
Great. Last question from microphone number 3, please.
Thank you very much for the very interesting talk. It was very relevant for me. I am an occupational therapist, so I work with people who have disabilities, grown-ups and children. I'm curious, do you work with the occupational therapists?
With engineering good, yes. We train the trainers, as in we work. We don't directly work with the users of the assistive devices, but we work with the therapists or the caregivers, the primary caregivers, because it's a skills transfer thing. So how to hack things and how to solder things and how to rethink something. So what happens a lot in these workshops is that these therapists or primary caregivers, they learn this new skill and then they immediately start thinking about what else they can modify or they can change, where they can apply these newfound skills. So you get all these ideas coming out because they understand the context. They know what is required. They know what's available in the market, and what's available in the market is expensive and also limited. So yeah, the focus of engineering good is to work with the primary caregiver.
Thank you. Please give Sada and Regina a great round of applause.
Also Ricardo, we miss Ricardo.
Hi, Ricardo.